Okay, so the caching is finished. I did forget to put back the add keep sign, so it actually didn't overwrite properly. And then in this section, this is not what we need, but you can use that. In the in the pyro wedges output path, sorry, not there. In the wedge sim, we forgot, I think, the last time to create the attribute name keep and the target parameter to actually set the path to keep. And I could actually make that work without export the environment and override, because the override kind of like, if I change the value here, forces the attributes to change over. So if we, as long as we create the target parameter, drag and drop our path, and then make it like an absolute path as opposed to relevant path, so it always starts with /obj instead of // and then if we put the attribute name properly, it ends up simulating as it should. So what I can do here now is that I put a file merge node after the simulation is finished. So it's pointing to my wedges, and instead of my wedge number, I use a backtick $slice. This is what the file merge node does, and then you just need to put the range is going to replace the $slice with 0 to 9, and then it's just going to load all the caches at the same time. So if I scrub, press play, it's going to load the simulations as they are supposed to spawn. So if I can make that a little bigger, obviously as more simulations it loads, slower it will get, but we can, I guess, just scrub a little bit more. And so on and so forth. So these are fairly reasonable amount of simulations. They're small, they are so far so good, and they don't live long because we're not interested in them after they kind of are gone, right? Because we're always looking forward to the camera most of the time, but it's kind of working quite well. It's working as expected, at least all the time. We are detecting bullet hits, and they are happening as they should. So if I press play here, and you're almost flying in between these two, that's pretty cool. Okay, so that's how we can occasionally create wedge simulations. It works quite well. I have a information here that says volume resolution was reduced to meet the texture limit. That's fine, because I have too many of them. Okay, so the next thing now we can do is maybe we should mark this section as well. We haven't created enough of our render nodes yet, but we probably can. So I'm gonna bring this down here, maybe select this guy as well. And this is our simulation part. I'm gonna give them a different color, name it Pyro Network. Okay, I guess we can organize it a little bit better. And okay, so the next thing now we were missing was our, if I focus on ship A, these the particle, the simulation. Oh, I have a missile here that we can hide from our ship look dev, as we're not using it at the moment. There's our ship look dev. Ship look dev is here. I guess at this point I can turn this back to auto update, and it should be a group, hopefully. Side lights, missiles. So I guess I can blast that here. Just the missile, not the whole thing. Okay, that's better. And now we need to look into how to create some kind of motion to these thrusters. Okay, so let's go back up, and what I want to do is to create my thruster effects. I suppose we can start with the ship A. Now what I want is to split my thrusters, these individual objects, at the ship look dev, which I have already done for you. So if I go and isolate the ID hot metal shape, and we will end up with, I'll go like this. So here is my all the hot metals. That's how I name them, because they get hot due to, I don't know, thruster tech. And I'm kind of all cleaning this information up, creating a what am I creating here? Group name direction, and let me see what we're doing here. Oh, I think I'm just creating if we individually check. So that's, I just fetched the model, one of these, using connectivity, because they don't have group names. And then I am not doing anything here. These are already in proper places. And I create a group called direction primitive. Why did I do that? I'm not actually even sure. Center, let's have a look what that does. Okay, so I create in the subnetwork. I think I'm just trying to figure out the normal direction. I find some polygons that are suitable to figure out the direction, I guess. Yes, that's how. So that's the bottom part of it, right? And then I create a normal on the points. I am getting the centroid of this object, which is here, right? And then I'm copying the normal from these points to the center point, and then I'm blasting everything else but keeping the points, calling it a center point, and then I'm merging it back with my original object, so I can then later fetch back my center point from here. Okay, so then let's create another geometry node now here under ship A, and I'm going to make sure that this doesn't have any transforms, so 0, 0, 0. So we're gonna constrain it by hooking them up like this, and we can call this one main thruster. We can go inside. Now we can object merge our thruster object, which is our main thruster, which is the one at the back, right? So we can leave this as is. I'm gonna pin it and go back into my ship look dev. And here's my main thruster. I think these are the ones at the back. Oh, this is broken now because of this, because this was a hand selection. Okay, so I have my back thrusters, which is our main thrusters. I'm gonna drop this guy here, which means now I have the thruster itself that I can isolate. That should be at the back of the ship. This doesn't feel like it's in the right place exactly. Maybe I need to go into this. If you look through the flight cam, now if we leave it as it is, it's not supposed to be here. It's supposed to be at the back of our ship. Oh, it's because we have scaling, I believe. I think we need to have the same scaling applied. Scale 5. Yeah, because we had the scaling. Maybe then we shouldn't apply the scaling here. Okay, just to make sure that this is correct. So I'm gonna remove the scaling from here. Oh, actually, this maybe is even better now. Like caches. Oh, okay. So we did scale it like that, right? So then I suppose we can come in here and scale our. Well, how do we bring in our object? Just to make sure, so we can put the scale at the back of it. It's coming from ship out. So where's our ship out? Ship out is here. So we can apply our, I guess, scaling here. It was uniform 5. And then if we go up here, no, it's too big. We broke it. I guess we need to do it properly. What we can do is, I think we made one mistake, that we probably shouldn't have changed our scaling here, because now I believe that's why our ships were looking so big. They were going through buildings, but we already defined our size and we already have our simulation, so I guess that's not a big deal. Although what doesn't match now is the if we zoom here, I think we're getting double transform here. I suppose we can scale this slightly in back to 0.5. Should kind of fix it. So I can apply this transform here, I suppose. And if I go 0.5, and if I have a look here, now they should be overlapping. Hopefully where they should be. Yes, so that's fine. Okay. Let's go back inside, create a normal swap. Based on points. I'm gonna scatter points now on this geometry here. 20,000 points. I can remove the relaxed iterations. I don't need to be having even sections out. Okay, so now what I need to do is I need to calculate the speed of my ship. Okay, because this object is moving in a different, it's not really being transformed within itself. So I'm going to create another node here that I may be able to use in several places. So I'm going to call this speed. If I dive inside, basically I'm just going to object merge, the object merge of ship A. So object merge, pin it into this object, which I'm going to now bake the world position, transformation position, into actual world positions here, so I can get the actual numbers of the positions. And I'm just gonna pack this so I know like it's one object, because that's the basically the position I need just to calculate the speed. And I'm gonna put a trail swap based on compute velocity. It's gonna give me the speed, and now I can, from this, using the speed, I can calculate the speed of my ship. Attribute wrangle. Okay, here we can write at, I can probably say v at direction equals, that's for our speed, normalized at v, that's our direction. I'm just reversing it to get the opposite angle, and f at speed equals length at v. Okay, so then I can call this null, and I'm gonna call this out speed. Okay, so this is gonna give me always the speed of my ship. And then if I go back at the object level again and go back, dive inside in my main swap, now I can do another object merge Can probably do the same thing in here, but I want to transform this actually, so no. And then I can bring in out speed. Now I can attribute copy my direction, speed, and velocity. Direction, speed, and V to my new object. It should give me the normalized direction, etc. Okay, so now let's drop in another attribute. We can probably override certain things. Speed to scale. Okay, so I guess I am limiting my speed here to a certain degree, but probably we can do that in a bit more interesting way. Okay, so let's drop in a turbulent noise in a WOP-SOP. I'm going to randomize the velocities a little bit in these points, because right now they're all coming from a single where are they? Velocity. So they were coming from a single point, and they're all moving the same speed, but we're going to create a little bit of a noise. So I can put a turbulent noise based on position, and then I want to multiply the output with my velocity. Output as my new velocity. That's going to be for my particles. Okay, so if we visualize the vectors here, you're gonna see some inconsistencies as opposed to what it used to be. Okay, so let's get some of these numbers outputted so we can play with them a bit easier. Offset and animation and amplitude. And I guess what I went was 7.3, 7.3, 7.3. Offset is, I'm offsetting it in every frame. So if I press play, so it's kind of like creating some crazy variation. And then we start from frame 100, right? So we can drop in a pop net to create some particles out of this. Select the source input. So there's going to be points, use first context. That's fine. And then in the BERT, I'm making them the very short, constant activation, and then BERT rate quite high. And then life expectancy is like 0.02, life variance is 0.03. And the positive, it should be fine. So if I press play, we won't see it here. I guess if I have a look here, remove those points. Oh, that's what I'm seeing. Okay, it's hard to see. Let's go back on the dark view. Okay, so it's just kind of like creating a really fast, rapidly changing thruster effect. So that should actually do the trick. And let's go back up one level. Oh, sorry, not here. Now we need to bring this, where are we here? So we need to cache this out in the, so this, remember this is our main thruster. So for everything else, we just need to change the input. Thruster, main. Okay, I'm gonna put it on manual. What I need to get is to, let's say, thruster effects. Copy this. Let's paste it in the object section. So this is what we get in the end. And if I press play, it should generate some points. But again, we have too many attributes that we don't want. So we can say an attribute delete here. And pretty much get rid of everything we don't need. And that's gonna be everything but velocity and ID, I believe. Pretty much everything else we don't need. and we can actually get rid of the group as well, so group delete. Okay, and delete unused groups. Okay, and then null out thruster, thruster, thruster. Okay, so now we just have to repeat this quite many times. But if you look from our field camera, we should be seeing those particles here. Behind our object, but this needs to be, it's parented, it should be getting the values from here. Doesn't look like it's been outputting it properly. Oh, I think my screen got stuck. That's what we're looking at. Because this is what we're supposed to be seeing when we go outside. And I don't see it. Okay, so it's there. Oh, okay, so we are going to opposite direction. Okay, I'm gonna hide the scatter and the landscape because it doesn't let me see it properly, I think, because I can see it here, but it's working the opposite direction, so I guess we can reverse it here, and that's what's happening most likely. I have a viewport issue, things are disappearing. Let me change my clipping again, I suppose, maybe something like this. And if I try to focus again, okay, so now they are looking towards the camera. Our camera is behind, so it's probably correct. So if I turn on the ship A, are they looking the wrong side? It's very hard to tell. Yes, they are looking at the opposite side. Okay, I guess this is where we are doing it wrong. In that case, we can reverse the initial. It should give us the correct direction. Okay, and now if you look from the flight cam, I suppose we are gonna see them properly. Okay, so now it's working. If it feels like it's too short, the only thing we need to do is, like, let's say we want something longer, and we can just go here and say -2 or 3. Okay, so the other thing that I want to probably do is to break that up a bit more, so you get more spiky look. I guess for that we can just increase the roughness. But that also amplifies the strength, so I guess we can then decrease the amplitude. So something like this will give a bit more broken up shapes, and the velocities should be fairly correct. Okay. So now we have our thrusters. So we can continue now by creating the other variations. So we can copy paste this guy. Now this is gonna be, here I gave them names. So thruster FB. So we can copy this name. This is main. So this thruster FB, right? So I can't focus here to see where it's gonna add, but if I go inside, then I can change my out thruster main to thruster FB, and that's gonna give me a side booster. Except though now the problem is what we are doing here. We don't want that. We need to get the group that we are interested in. So we can put a group swap to we should have the center ID hot metal shape direction. So we are interested in this guy to emit. So we can do put a blast. That should just give us this, and that should just scatter the points on there. Except though, now we have one problem, is that our ship will be moving too fast for us to manage to push something forward reasonably. So we don't actually now need to get the this section, and we can only emit based on the normal. So at the moment, if I check the point normals, which is fine, and then I don't have velocity, so I just want to shoot stuff out from the tip of the nose all the time pretty much. So in this case I can just create I can do this in the up here as well. This is my normal, so basically I want to use my normal as my vector, so pretty much that. So if I turn this on, it should give me a vector. Do I have my normals here? Show all. I should have my normals. Yes, I do. So where is my velocity? I don't have velocity here, but I can output velocity from here. So that's my pretty much my velocity now. My normals I use like my velocity, so I'm gonna bring this back in and multiply my position with my velocity, but I guess we can't use something small here, so this kind of changing it too much. It's almost, for some reason it's setting it to 0, which is not what we need to do. Oh, because I'm multiplying the velocity, so that's wrong. So we need to bring in the normals, right? Okay, so if I can see some blue in there now. Okay, so this is kind of changing it a bit too much. Okay, let's stick to this for now. We can add, we can randomize it in our .NET. Okay, so if I turn this off, and if I try to get my shape, so we not to shoot down, we are shooting up. So let's dive inside. Let's change it to 2. So now it's going to be shooting down. If you press play, if I look through the flight cam or cam 2, I don't think I see it here. Oh yeah, so if I press play, so that's what it's doing. It doesn't look like it's moving now, but it actually is. We just need to go to the object level, and then if I press play and then zoom in, you'll see that it's actually moving. Let's back inside, press play. We need to randomize this a little bit now. So let's go inside, maybe add to inherited velocity. Okay, something like this should suffice. Okay, it leaves just as long as it needs to. And that's another thruster. Okay, so I'll continue duplicating these the same way. We just have to create one for each of these layers, and we'll get back to you, so to keep the video a bit shorter. Okay, so in the previous lesson we were doing the thruster technology from this ship, but I think I'm just gonna ditch that, because as I keep doing it, I realized that my original workflow was a bit not so solid. So I think I just want to make a new one from scratch, together while recording this video, of course. I think because we are originally importing our object from the lookdev ship out, so I'm just gonna make sure that everything that I split here, it actually goes into the ship out, because this is what we're bringing in, right? So what I want to make sure that is I do have properly fixed thrusters so I can use them properly in my simulation. So as I have already explained, I have ID metal shape here that just isolates this. So at this section now I want to remove the thrusters. So when I merge it with this, I can get the proper connection. So I just want to make sure that I have the proper grouping, and if I don't, I'm gonna split them now. This is kind of broken. Why is this broken here? That's probably because I have changed, because I blasted the missiles. Yes, so I want to blast the missiles then in the end. Or it's because the geometry shape change. I think the geometry, maybe in between my renders, in between my when I was rebaking this, it changed the vertex order somehow. So now it's actually breaking what I need to. Oh no, this is actually correct. So that's correct. That is also correct. Okay, so no, that's fine. Never mind. So I isolated the ID hot metal. So I removed it from the main body, and I have these guys here that isolates them. So now what I want to make sure that is the thruster. So I want to make sure that I can split these somehow. And then if I merge all this, I should get the direction. So if I then blast it again, just to see if I get the proper vectors, delete not selected, direction, and I get what I need here, yes. And all I'm just gonna require is also the main, which is here. So let's move this guy here. These are my this is the back thrusters as well. I think this may need its own sim. Emissive ID. Okay, so this we will probably need to isolate slightly better. So let's group this as well. Let's call this the main thruster here. Main thruster. Okay, so now I can merge these guys here. Now finally, probably bring this here, and that should now give me everything except I want to remove the missile at the end also. Okay, so there's a one problematic area is the thrusters. Where was it coming from here? It's because we need to get it from here, so it should probably fit in its place. Okay, so ship out. Let's give this a black color. I'm gonna overwrite again, file, save. Okay, let's go to object level. So now everything I need is coming into my ship A, which has its own transform coming from the chopstick, but I want to bake that down, right? So I'm going to create another geometry node. I'm going to call this thrusters. Thrusters. Let's go inside. Let's object merge. Now we're going to object merge our ship using into this object to get the world translation of our particles, of our ships, which causes another issue actually. So maybe I'm not going to do it like that, but I'm going to create it. Maybe I should actually show what the problem might be. Okay. Generally, when we receive an animation, the spaceship might be going like 5,000 kilometers an hour, and these things very often, trust me, happens. So no matter what you do, no matter what you plug in, you end up with something that moves super fast and usually causes a lot of problems in order to do some simulation. So if I now put a blast node to get my emitters out, and then I can delete non-selected. Okay, so this is one of my emitters. Now they should be moving properly. Yes, they are. 1 second. Now I need to double check from the other side. Okay, so now if I were to emit from these objects using their normal as a velocity, which we can try, we can actually remove what we don't need in this case, because particles do inherit all these attributes. So let's remove the CD, let's remove the class, name, test. These are all coming from my nodes. Okay, so let's drop in a normal swap. Okay, from points, visualize it, it looks correct. Visualize all of them. It doesn't look like they are reverted. It looks all good. Okay. And then if I were to emit particles from these guys based on the normal, so I'm gonna rename actually, attribute rename, normals to velocity. So that's n to phi, and if I put a particle network here, pop network, and let's say I just want to emit from the surface, right? Let's plug in a flight cam here. Let's say I want to emit from the surface like we did before, like 0.4, 0.4 or 0.3 or whatever. Let's go 50,000. So if I press play, something weird is going to happen because our object is moving forward and we're going to get this stepping that is very obvious. Okay, so we want to avoid that. Since this is an effect that kind of just stays with the ship, what we can do instead is to actually instead of bringing in here, we'll just bring it in as in none, which means that it's not going to be moving because it's not going to inherit the transforms. Okay, but if we press play, now they're not going anywhere. Correct. Now, so we can re-instance this, relink it to our object, but I guess first we need to get the simulation looking a bit more interesting, obviously. So let's go, I guess, less points, more speed, and more random. So we want to inherit the velocity. I guess we can go 3 and just press play. Okay, so that's kind of working, but it's too spready. And it's leaving too long, so maybe let's go like this. We press play. Okay, maybe still a bit too much in terms of distance. Maybe okay, let's go like that. Now 0.4. I'm gonna try 0.4. If I press play, okay, it's a bit more like it. So now what I want is to show you what happens when we link it to the thrusters. That should now move with our ship. So if we look, if I press play, so now our yellow particles, as you can see, is kind of sticking to our ship and it's moving with it, so which is fine, and this is what we want, just to create a little haze under pretty much. Okay. Again, we're gonna do an attribute delete because we're all about optimization, because like I mentioned, the particles do come with everything that comes out from the sim. So we'll call this thruster. I am really keep writing it wrong. Thruster object name, we just want to fetch out object name. Remember, if we have collision object, those are going to come out just like this as well if we just plug in anything. And from here, what we need is, did I write it wrong? Thruster. Okay. We need velocity, probably H for shading, and ID as well in case we retime it. And we don't need anything else, but syntax is like this, right? Star, Shift 6 is for excluding, and remove the other attributes. Group delete. Okay, let's group delete as well. Okay, so that's, I believe it's pretty cool. So the rest is about amount and how much we want to put in here. We're gonna work on the color as well a little bit, and the mass a little bit as well, because we're gonna add some drag. So which means if we come here, we're gonna emit actually from points. We're gonna go scatter because we may not have enough resolution there. I'm gonna go 10,000, and we're gonna probably, let's change the seed every frame. And if I go inside now, I need to change my source to points. Okay, so I guess we can put another 0 here. Now what we want is to randomize our shape a little bit, so we can add a drop in a popnet, wopnet, sorry, point wop. Okay, let's focus on one of these guys. We're gonna look in the colors. I'm gonna bring my background to light. Okay, as usual, dropping a turbulent noise just to see the color variation is kind of working. I guess that's fine for now. Actually, I'm gonna go in here. I'm gonna lock my parameters here, and I'm gonna export this color as a mass. So bind export mass. Okay. Which means that I don't need the color anymore. Now I'm gonna add a pop drag, and it's gonna be something really small, but it's gonna be working with the mass. So if I press play, okay, maybe we need more. I guess our values are too much. Oh, we're not living long enough. I guess that's what's happening. In order for us to check that, we need to maybe give a bit more life expectancy. Nope, still too fast. Okay, I guess something like this. This is the side thrusters. I think that's still a bit too much. Let's go to. Okay, this is not kind of working too well because I think we're too fast. So what we can do then, change our source based on our mass or color. So we can change the shape a little bit. So let's, I guess, export frequency, promote, amplitude, roughness, all that stuff. And I'm not going to use the mass anymore. I'm just going to use the color to remove the points. In order for me to just see that, I'm just going to increase that a little bit more so I have more points so I can see the color. I think our frequency, okay, so our frequency was too low. Maybe that's why the mass wasn't properly working. So I can introduce some roughness. Okay, so now I can see the difference, right? Change the points to points because usually it's difficult to see. Okay. So now I can see it a lot better. So now if I go like a $F on one axis, if I change the frames, we're gonna see that it's kind of moving, which means if we drop in an attribute wrangle here, and let's bring that out again, let's call it mass. Okay. So I'm gonna remove the certain amount of points by saying if f at mass is less than 0.5, remove point at ptmam. Okay, we'll learn this for now. Okay, maybe 0.5 is too much. 0.2. Okay. So now I think this is kind of gonna, okay, so it's shifting around. I want to get a bit more nicer shapes. Let's try again. Okay, so every now and then we get some gaps. Maybe it's gonna produce something a bit more interesting. Okay, and let's give them a color based on age. I think they are, I don't think they live really long, but there should be some kind of age variation. Yes. So if I load any frame here, maybe put a color swap and ramp from attribute. If I go H, and what is my minimum is 0, maximum is 0.2, right? So it kind of gives me the fall off I need, which means I need to start hot and cool down. So black is gonna be my white, or we can go blue, it depends on how you want it to shade this thing. And then a bit more red, I guess. Now let's get rid of this. Oh, it's supposed to be dark. And yellow somewhere here. The usual heat colors. Oh, I think we need to do this the opposite way. So let's just move this around. Okay. So here are thrusters. Now thruster. This time I wrote it right. So if you look through the flight cam, so these are our thrusters. We just need the yeah, I think they're still a bit too long, but they are just for creating a little heat haze, I believe. Okay, so let's do the main thruster as well. The main thruster is coming from our, not direction, but we gave it a name. No, it's the emissive one. Yes. Okay, so that's almost correct. Now I think we had the main thruster here. Yes. Okay, so that's better. This is gonna do the same thing, so we might as well just copy paste it and see what it does. If you don't like it, we can change it. I guess we just need these to be a bit longer. So we can go like, I don't know, 5. Press play, let's see what it does. Okay, that's our thruster then. Maybe even more. 7. Okay, thruster main. So let me merge these. Okay, I really would like, I think, these guys to be a bit more subtle, so I'm gonna go 4 for this. And I'm gonna make sure this guy is a bit short as well, so I'm gonna go 1. And if I press play now, get something more subtle. Let's look from the flight cam. Okay, that's more subtle. And we're gonna do the same thing for ship B, which means copy paste. In this case, it's just gonna take a bit longer because there's more nodes inside now. And literally, we're gonna bring this to ship B here, and we're gonna change ship A to ship B, and that should do the rest of the job. And now both of our ships have thrusters. Yes. And let's have a look here. If you press play, it's gonna be a little slower, so that needs to be cached out as well. So let's do that. File cache. I don't want somewhere else. So where can I find something I cached properly? Is here. One of these guys. So these are fast particles. I can save them under my folder, my hip folder, which is a lot faster to load. So I just have to give it a proper name. Thruster A, thruster. This is A. thruster A, load, and the other one is going to be thruster B. Oh, wrong paste. That's gonna be go in here, copy again, copy, okay, thruster B, paste, and name it as B, and thruster B. And I'm gonna bake these, and I'll come back right after updating this from ages 600. Okay, let's cook these and then we'll get back to the lesson. So yeah, now it's all cooked and baked. If you press play, kind of look fine. Okay, so it's just a little touch, but if we have for example a bit like a closer camera, something like this that reflects nicely on the engine, it looks a bit more interesting. It creates a little glimmer, etc. So it's just a bit more, you know, a bit more interesting. This is the camera shot pilot HOD. I am closing the windows to look through so I can see properly. If you press play, okay. All right, yeah. So now we created our thrusters as well, which are cached out. It's a bit more efficient than what I was doing before, I think. Just a bit more simple, but it does the job, at least for this version. It's not going to win any awards, but it kind of tells you the story on how a job like this can be approached. I have been lately thinking that I've been giving a lot of general information in my last 3 tutorials, but it's kind of like an overall preparation for Houdini workflows. So I'm planning to actually make some more focused training videos. Next one will be most likely about rigid bodies, mostly about destruction, but so some trees and some ground and the houses, so that I can also give some information about how I actually finally try to address nodes if we need to, if we get like supervisor feedback, which I don't do shots anymore, but at least that's how I used to do it. So in this case now we have the bullets. I'm gonna turn that on here. We have the pyro. It's also turned on here. If I'm to forward a little bit. Every time the buildings get hit, we get a nice little explosion, and then we fly through them, which is pretty cool, which are gonna light the environment. I wonder what I can further add is, yeah, so we were shooting some missiles. That's the part that we can move next. Okay, so the next tutorial will be, the next video will be about some random missiles that we see in my videos. And finally, we're gonna create a little bus crash scenario. So one of these ships will go through a bus crash, and we will conclude the tutorial with the setting up of some of these cameras with our render layers using Redshift, and then finally we will finish our tutorial. So thank you for watching, and then we will start building our missiles in the next video.